Hello and welcome to this video lecture series on sorting algorithms. Sorting algorithm forms a very important topic in DSA, and it's very important that you understand the concepts behind it. Okay, so let's start the video. What is a sorting algorithm? In computer science, a sorting algorithm is an algorithm that puts elements of a list into an order. For example, arranging elements or arranging numbers in descending order. Okay, so one more practical example would be the contact list in a phone, which is sorted alphabetically, which allows us easier access to the contacts, right? So now, what is in-place sorting? An in-place sorting algorithm uses constant space for producing the output. It sorts the list only by modifying the order of the elements within the list. And there'll be a pop-up link at the top right corner of the screen which explains time and space complexity. So if you are not familiar with these concepts, please go to that link so that you have a fair understanding of what time and space complexities are. Insertion sort and selection sorts are examples of in-place sorting. Next, the types of sorting. We have two types, internal sorting and external sorting. When all the data is placed in the main memory or internal memory, for example RAM and ROM, then sorting is called internal sorting. In internal sorting, the problem cannot take input beyond its size. Next, we have external sorting. When all the data that needs to be sorted cannot be placed in memory at a time, the sorting is called external sorting. Some external storage like hard disks, CD, etc. are used for external sorting. The next topic that we have is stable sorting. So when two same data appear in the same order in sorted data without changing their position, it is called stable sort. Next, we have unstable sorting. When two same data appear in different order in sorted data, it is called unstable sort. So let us now try to understand stable sorting and unstable sorting using an example. Suppose we have this table having two columns, name and age, and we have four different names with their corresponding ages. So now what I want to do is I want to sort this table based on the age. So once we do that, we can see that the ages are sorted in ascending order. Okay, so 19, 21, 23, 25 all are in a sequence. So once this is done, what I want to do is I want to sort this table based on the name. Okay, and when I do that, we can have two situations, right? So one situation is when Aaron with the alphabet A comes at the top position, then comes Bam, then comes Pam, and the other Pam, right? But note that these two are similar elements. In terms of the name, they have the same name, right? So when we try to sort it based on a name and the sequence is maintained, for example, Pam 23 was above Pam 25 when we sorted based on the age, and that consistency was still there once we sorted based on the name. So that will be an example of stable sorting. So the other case that we can have is name. When we sort it based on the name, we'll have Aaron at the top, then comes Pam, and Pam 25 comes above Pam 23. Okay, so in this case the original order is not maintained. Okay, so it got shuffled, and so it is not a stable sorting. So it will be a case of unstable sorting. I hope you found this video helpful, and this is it, and I'll see you guys very soon. Thank you so much for sticking by.